This is the semester exam review over vectors. Please remember that vectors are any object. It can be anything with a direction. So anything with a direction is a vector. This can be a velocity, a displacement, a force. Any of these things can be vectors. And there are more available too, but these are the three that we talked about a lot. Alright? So first thing we need to know about vectors is that if they're going the same direction, right, like this, 5 meters per second, let's say that we had a car going 5 meters per second, and there's a wind blowing the car from behind at 2 meters per second, the final speed of the car is going to be 7 meters per second. And if we had same car going 5 meters per second, but the wind is blowing against the car this way at 2 meters per second, now the car is going 3 meters per second. Okay? Now, the reason we know this is true is because whenever we add vectors, we have to, if they're going the same direction, we add them together. If they're going the opposite direction, we subtract them. All right? And this is only if they're on the same plane. So in this case, both of these are on the x-axis. If they're both on the y-axis, that's all well and good too. For instance, if we have a box sitting on the ground, there's a force normal pushing up and a force of gravity pushing down. And then if we wanted to add those two forces together, we would call that the resultant force. Remember, the resultant force or the resultant velocity. Resultant is the sum of two forces, or sorry, sum of two or more vectors. So if we wanted to find the resultant force, we would do the normal force plus the force of gravity. And since the gravity is going down, eventually we would know that that would be be negative force of gravity. Okay? So there we go. That's how you would add vectors if they're in the same direction. If, on the other hand, we had a plane flying at 4 meters per second this way, and we had a wind coming in at 3 meters per second this way, now we have a situation where we are going to have to do vector math. And the way you do vector math, remember, is there's 5 steps. 1, add the x's. 2, add the y's. 3, redraw. 4, do the Pythagorean theorem. And then if you have to, there's the 5th step of finding the angle, which will be tangent -1 y over x. This is not always necessary, but if it asks for the angle, that's how you would find it. Alright, so in this particular case, if we're looking at it, there's only one x, which is convenient. It's 4 meters per second. There's only one y, which is convenient. It's 3 meters per second. And so we would add them together. We would redraw. Now we redraw. So we draw the x first, 4 meters per second. Then the y, 3 meters per second. Now we've got a nice little right triangle, and this will be the resultant velocity. So the resultant velocity, remember, or the resultant vector at any condition is equal to x squared plus y squared square rooted. So that would be equal to 3 squared plus 4 squared square rooted, or the resultant velocity would be 5 meters per second. If you had to, you could plug this in and find the angle. The angle would be equal to the inverse tangent of 3 over 4. And you'd be finding that angle right there. Okay? This is for velocities. What if we had a forces? Force, sometimes you can have lots of forces acting on it. So if we have this object where we have 10 newtons up, 6 down, 3 right, and 6 left. Sorry, and 6 left. Now we've got a different situation. Same 5 steps. 1, add the x's. Well, we would do 3 plus a -6, and we get x equals -3. For y, we would do 10 plus -6, and we would get y equals 4. So if we drew this, so we've done our first step, we've done our second step, Third step is to redraw. So we're going to redraw it and go x first. So we go back 3 and then up 4, and now we have our resultant force here. And so our resultant force, sorry, can't write. Our resultant force would be the Pythagorean theorem. Resultant force equals the square root of x squared plus y squared, which would be the square root of 3 squared plus 4 squared, and we would get 5 newtons. Okay? And then if we needed to, we could do inverse tangent y over x, which in this case would be 4 over negative 3, and you could plug that in the calculator and get the answer. And that would be your angle right there. Alright, that is how you do vector math. So anytime you've got stuff going at some stuff in the x and some stuff in the y, you've got to do your vector math, and that's how you do it.